proponent of AAC, and also wanted to share that I know the research does show, if people are ever concerned, will it prevent my child from becoming verbal? Research actually shows that it can increase, verbal abilities, and they can work, hand in hand and in multimodal communication. So thank you for that.
Yeah.
So I'm going to share my screen. Okay. Great. So as many of you know, I'm Ashley Waterman, and I'm mom to Liam, who's 4.5 and has Cohen syndrome, and I live in Los Angeles. Thank you so much to everyone from the Cohen Syndrome Association for having me on today and for all of your support. I've loved being a board member and participating in this conference and these efforts. And thank you, Dr. Wong, for all your support as well. So I'm here today as a proud board member of the Cohen Syndrome Association and the Cohen Syndrome Research Foundation. So I'm excited to share with you what that is. And I actually wanted to start my presentation by sharing the Luxturna story. And hopefully everyone has already heard this idea a little bit, because Dr. Klein shared before that the first FDA-approved gene therapy ever was for an inherited retinal disease. So that's really exciting and gives our community a lot of hope, because this is really a new day. And for the first time, I can stand in front of you and say that a treatment for Cohen syndrome that could restore vision, improve intellectual abilities, and neutropenia is really on the horizon. I think I'm going to skip this video because I just want it to be fluid and I don't know what the sound will be like. But this is one of the stories of one of the first Luxturna recipients, and it's on Luxturna's website. And this is a man named Sean in his 30s, and he had retinitis pigmentosa due to the other gene that Luxturna treats, so not Cohen syndrome. But he was, legally blind by age 7, and in his 30s received this gene therapy and could see again at night. And he's actually a football coach, so I thought it was a very inspiring story. And as I mentioned before, we are not Luxturna, but what Luxturna did for the RPE65 gene can one day be possible for the VPS13B gene, for our Cohen syndrome gene. So when we mobilize our community, we can advance research and attract interest from researchers and the pharmaceutical community. Luxturna was the first, but now there are dozens of other advanced efforts for many, many rare diseases that are changing the lives of children and adults born with genetic conditions. So Cohen syndrome has never mobilized our community resources for these efforts, and now is the time, because the technology is finally here. So we are the Cohen Syndrome Research Foundation. We're here to harness the resources of our community and to really make a difference in the lives of our children. So there's 2 pathways to success. Did you know there's no wizard behind the curtain, no government, no medical research, pharmaceutical companies coming in to help our children who have rare diseases? And I'm sure all of you have experienced that many doctors we see aren't familiar with Cohen syndrome until we educate them. So we actually learn to speak a language that has nothing to do with our former lives. And those living with ultra rare diseases basically don't exist to the scientific community unless families like ours get together and hunt down the special brains to help us out. We raise money and fund research to understand our disease and to help develop treatments to better our children's lives in the most meaningful way. So we can't do this alone, and we hope everyone will help us. And there's a few pathways that we want to discuss that will help us get there. So the first is clinical research. So what is clinical research? Clinical research is the comprehensive study of the safety and effectiveness of the most promising advances in patient care. And there are 2 types of clinical research. There's observational studies, and then there's clinical trials. And the only way that medical advancements can be made is if people volunteer to participate in clinical research. So you or your child, the potential research participant, is just as necessary as the researcher in this partnership. And before we can begin to explore clinical trials for treatments that might help our children, we need to understand the phenotype of Cohen syndrome. And the phenotype is the observable characteristics in our patient population. This is why studies like Citizen are so key. We need to have a picture of how an individual with Cohen syndrome evolves over time, so that when we do have clinical trials available, we can see how the drug changes the outcomes. Our first effort towards gaining knowledge about our population is the Citizen Digital Natural History Study. So many of you may have seen the announcements that we made on the Parents of Cohen Syndrome group and on the new Cohen Syndrome Research Foundation group or on our Instagram. And we have joined in partnership with Invite Citizen, Rare Patient Network, we've joined this digital natural history study. So what that means is that we can build a strong natural history study from patients' medical records. And signing up is free, and it only takes 10 minutes. And it's really exciting for families because you then get access to all your medical records in one place. Medical records expire usually after 10 years at any institution, and you will have all of this information at your fingertips, and your records will help researchers gain a better understanding of Cohen syndrome. The information in Citizen is all de-identified, and then one day will be made available to any researcher that wants to access it for their research. And so that means that researchers can access information of patients that come from a multitude of different, hospitals and clinics, not just from one doctor. So that is, really exciting. And when we move towards clinical trials, we will need things that we can measure. And we are all aware that our lives are busy, and caring for our children, takes a lot of energy and efforts and advocating. And we know that these forms can be overwhelming. And we're here to help you. We'll be announcing another webinar soon with the staff from Citizen that will answer every question and even sign up and do a Zoom call with you to help you sign up. And so again, we know it's overwhelming, but when we recruit a large number of individuals who have different presentations, we can begin to understand why certain individuals with CS with Cohen syndrome have a very different presentation. So participating in genetic research really gives us the opportunity to understand also what other factors contribute to the severity. So we really hope that everyone will participate in Citizen. Fortunately, right now, it's for US only, United States patients only, but they are working on it and it's around the corner. So we're excited to gather as many participants from our community as we can. I also wanted to share one project we've been working on, which is the Cohen Syndrome Working Group. So in the absence of systematic data on our population, which we hope to collect through Citizen and other natural history studies, we have created a working group of nationwide experts to provide expert recommendations. So about 2 years ago, the Cohen Syndrome Research Foundation brought together a group of Cohen syndrome experts in genetics, neutropenia, anesthesiology, vision, neurology, primary care pediatrics, protein function, and molecular therapeutics. And this started as a partnership because Liam receives most of his care at UCLA. And so this started as a partnership with his developmental pediatrician who had a grant through an autism intervention research network on physical health. And they've had a graduate student who's helping us to work on this. And after months of collaboration, the group created a combined paper that will be submitted for publication this fall to the Orphanet Journal of Rare Disease. So this paper, while it's not a substitute for a natural history study or a registry, but we're really hopeful that these efforts will represent a comprehensive resource for patients, families, and doctors. Because we all remember what it was like the first day when our children were diagnosed. What does it mean? What are the outcomes? What do I need to do to keep my children safe and healthy? What does it mean for my life? So I know we've had a lot of these questions, and we're really hoping that this paper, people reach out to me, through our group and say, I have this diagnosis. What does it mean? What doctors do I need to see? And we're always helping each other as a community to answer these questions, but this will be, in an organized paper, and it will be a resource for patients as well as for physicians. We're also hoping that in the absence of the natural history study, this will assist with insurance issues to get Neupogen and other drugs covered. Okay. So now we're going to switch a little bit more into the science, a very brief overview of the science and translational research and some of the possibilities with research. And I'm going to turn it over to my husband, Ben, Liam's dad, since he's a doctor and understands the science a lot more. And then I'll be back. So thank you everyone so much. I'll see you in a minute.
Okay. Hi, everybody. I'm Ben Waterman. I am, as Ashley said, Liam's dad. I'm the chief medical officer of a hospital, an internist who works with adult patients both in primary care clinic as well as in the hospital setting. I will just a bit, I think one of the things that's really important to recognize about research, especially basic science research, before we proceed, is that the skills that one develops as a clinician, the things that I go to medical school for, that I learn about when I see my patients, that even a lot of our physician colleagues spoke about today, are very different than the skill set that's required when we talk about basic science research. This is really, at the bench in a laboratory using pipettes, diluting samples, splicing genes, transfecting them into cells, or using viruses and such. And so that skill set is really disparate. And while I understand a lot of the language and the jargon, I am by no means an expert in all of the different areas that are required and really prerequisites to launch a successful basic science and even translational research campaign. And so because of that, one of the things that we're really looking to do is build a panel of experts. Because even, a lot of the people that deal with Cohen syndrome on a daily basis, or parents, we're not equipped with the tools to really assess 15 different scientific proposals from people across the world who all have expertise in different areas to really understand which of these deserves funding, which we should move forward. And so one of the first things that we're doing before we even begin to talk about the different sort of areas that we're focusing on is assemble a scientific advisory board with experts from around the country in areas relevant to Cohen syndrome. And so everything from, people who are expert in the Golgi, because we think that the protein, we know the protein localizes to the Golgi, which is one of the little organelles inside the cell, to people that are experts in gene therapy delivery, which is what was spoken about previously by the ophthalmologist around using viruses to deliver basically genetic material to cells. All the way to sort of people who sequence genes within industry and trying to form partnerships to understand the prevalence of the gene. And that will yield insights into maybe some types of mutations that are less severe than others. And that has implications for research and discovery as well. So the first thing, there's so much groundwork that has to be done to assemble the right people and the right approach to research. It is certainly a non-trivial process. And I would say, we are still, we're in sort of the middle stages of just building the infrastructure that's required to really tackle such a huge problem. So I just want to talk a little bit about some of the foci, if you will, that we are targeting as we begin this journey. I'm actually going to start with number 4, and the interesting thing about Cohen, and it's an opportunity. I think some things where there's challenges, there also can be phrased as opportunities. There is precious little information in the scientific literature about the function of the VPS13B protein. So remember, our genes code for their DNA, they code for RNA, and then the RNA gets moved to different parts of the cell, the endoplasmic reticulum, the Golgi apparatus. I'm sorry if this sounds Greek. And basically they get translated into proteins. And so the problem that we have with Cohen syndrome is that the gene is not working, which means that the protein is non-functional, or at least only partially functional for our children and our loved ones. And in order to really understand at the bench, before we even start thinking about testing in mice or in humans, how do we even know that a drug is working to fix the protein? How do we know, what? And in order to understand that, we really need to know more about what the protein does. Right now, we know that it goes to the Golgi, and there's a lot of, sort of data that suggests that it's involved in sort of packaging and sorting different proteins and lipids in particular, actually, as they're sent around the cell. But we actually don't know specifically what it does, which makes studying sort of whether drugs are efficacious, whether treatments are efficacious, whether gene therapy is efficacious, really challenging. So one of the first things that we need to really focus on is what is the function in detail of this protein? And that will really yield results that will help us with our further journey, as I'm about to discuss. So the other key areas that we're currently looking at, and this is not comprehensive, this is just some of them. One is drug repurposing. Wouldn't it be amazing, and this has been done in some rare diseases, wouldn't it be amazing if there was already an off-the-shelf drug that was already approved by the FDA for a different reason, and when you treat cells from children or adults with Cohen syndrome, all of a sudden the abnormal things we see in Cohen syndrome cells, if that changed and the cells look normal and the protein function was restored. Again, this is not easy to do. In fact, it's harnessing a lot of artificial intelligence to hypothesize even before we start testing how different compounds will interact with the protein to potentially restore function. But that being said, it is an approach that's been successful. And if you can find an off-the-shelf product, obviously all of the barriers in terms of clinical trials, in terms of safety research and things of that nature are much, much easier and faster versus developing an entirely new gene therapy approach or an entirely new drug that's never been synthesized before. So that's sort of the low-hanging fruit that we think we need to look into. Again, obviously there's, we're hopeful, and there are, I would say, in the last week, myself, Ashley, some scientists that we've already started to recruit onto our scientific advisory board have met with over 3 different researchers, Courtney as well, who's Ashley's co-founder, 3 different researchers and labs talking to them about their existing projects, many of whom are looking into drug repurposing, and some of them have already identified promising candidates. And I don't want to get everyone's hopes up too much because obviously there's a long way to go, but we're already starting to see yield on a lot of these efforts. The second thing I want to talk about is the mini gene. Our ophthalmologist colleague did a wonderful job talking about the Luxturna program and just how exciting it is for everyone who's affected by rare diseases. What they use is, I think she mentioned this, an AAV, which is a certain type of virus. It's an adenovirus that takes genetic material and takes it from a virus. It gets injected with that long needle into the eye, and then the virus basically injects the genetic material into the cells, and that replaces the damaged gene inside the cell. The reason that this is a bit harder with Cohen is the size of our particular protein. Our gene is about 3 times the size of what an adenovirus, an AAV, can hold to shoot that genetic material into the cells themselves, which means we either need to find a different vector, a different way of shooting the material into cells, or we have to shrink the gene itself and shrink the protein so that it can fit inside the vectors that have already been established. And this has again been done in other rare diseases where they have a larger gene and they cut out certain parts of that gene and certain parts of the protein that are maybe less relevant to function. And they can restore at least some function, which is good enough to basically change the way our kids develop. And so one of the things that we're also looking at is, are there parts of the gene itself that can be removed because they're not as necessary, so that we can actually develop a fully functional smaller protein or a fully functional or a partially functional smaller protein that would treat our children. So that's another one that again has been done in other laboratories for other rare diseases and is a promising approach for us as we move forward. The other one, antisense oligonucleotide, this one's a bit more complicated. I'm not going to go into great depth with it. It again has been shown to be helpful. Basically what they can do is, if your child has a genetic error in one part of the gene, so you guys have seen, I think there were some questions like, there's 250 different errors in the gene in Cohen syndrome that currently cause the phenotype, the way that our children develop and present and their limited vision and things of that nature. So if you can block out the part that's damaged, you may be able to, again, and this is called an antisense oligonucleotide, you may be able to have a protein that's not quite as big as the normal one, but maybe just a bit smaller, that will actually still be functional. And again, this has been done already in certain rare diseases and is in clinical trials and others. And so again, it's a promising area. I think there's a lot more that we could certainly cover. I think that, the studies that were introduced or the research opportunities by Dr. Wong and Dr. Hang, in their group previously were wonderful things. And those are the types of things as well in terms of looking at biomarkers, hydroxylation, other sort of areas that we really want to champion and fund. And I think the most important thing about this is that we have, again, I lack the tools, Courtney lacks the tools, Ashley lacks the tools, but the first step is getting that expert body of researchers together who are literally world experts in all of these different areas to assess independently with no bias all of the different proposals that we're getting from researchers interested in this area and decide which avenues are most promising, and then basically take money that we raise and then allocate those funds to those researchers who are most likely to develop treatments and therapies and other resources for our children and our loved ones affected by this syndrome. So again, it's a very exciting time. I don't think that we would be sitting here in front of you even 5 years ago because this field has just advanced so much. And it's only a matter of time for the tools to be developed for us to actually make a tangible and real difference in our children's lives. And so I'm just extremely excited, and I look forward to all of your, to engaging you further. We're going to have seminars, we're going to have teachings. The science, again, is complicated. We're going to try to break it down so that people can understand a lot of it. And we look forward to engaging with you. The only way that we will be successful is if we can engage each and every one of you in this effort. It takes a village, and it's just too big of a task for us to do this alone. And so please reach out to myself, reach out to Ashley, reach out to Courtney. Again, we look forward to partnering with Dr. Wong moving forward. We look forward to reviewing the research proposals that he develops to really try to develop a strong infrastructure to move this process forward. With that, I'll turn it back over to Ashley.
And then you can stay on after for questions.
And I will stay on after for questions as well. Again, we've met with 3 of the most promising basic science research teams in the last week, really, to assess their current efforts and where we're at. So I'm happy to take any questions from that moving forward as well. So.
Yeah, I'll just finish up. So as Ben and I referenced, so Courtney and I are the co-founders of the Cohen Syndrome Research Foundation. And Courtney is the mom of Mitchell, who's 3, and they live in Omaha. But today, which is super exciting, Courtney and Robin and John are the parents of Max in New Jersey. And Robin and Courtney really championed this $1 million bike ride this year. And they're actually there today. They rode and walked in the bike ride. It's just a really exciting time with so many things, going on. And the $1 million bike ride is an incredible effort to raise funds for Cohen Syndrome Research. So thank you so much to everyone who has participated. The link is still open if you'd like to. It's really cool because University of Penn matches. If we raise $30,000, they'll match $30,000. So that's $60,000 that we can then have towards funding an important research project in the different areas like Ben mentioned. And we're really close. I think we're at about 27,000 now. And just to recap, I want to share what our foundation has done so far. So in 2021, we formed the Cohen Syndrome Research Foundation. In 2022, we established the Cohen Syndrome Working Group at UCLA. Later that year, we received our tax-exempt status from the IRS. And at the end of last year, we had our first meeting of the board of directors. So this year, as Ben mentioned, what we've really been focusing on is identifying scientific advisors. Courtney and I have been attending entrepreneurial rare disease, boot camps just to meet everyone and everyone we can, constantly speaking to other founders of other rare disease groups and really just learning, who are the best people to help us to create this, research roadmap to be as strategic as possible about the projects that we fund. And next steps. So as I mentioned, please, everyone in the US, because right now it's limited to the US, but it will expand, register for the Citizen Natural History Study. I'm also going to send out an email announcing an upcoming informational webinar with the staff from Citizen so that they can be there to answer any questions or concerns that anyone might have and help you with this process, even though I promise you it's really simple. It's like 10 minutes. We're also developing a patient survey because we really want you guys to help us shape the research priorities as well. So we'll probably get that out in the next week or so. And then we are going to also hold a scientific research update meeting with Mohammed Ansar and his lab. And I think many of you know Mohammed Ansar, as he is a geneticist and he's also a parent of a child with Cohen syndrome. So these are some different ways that you can get involved. And as Ben said, as I said, there's no way we can do this alone. It's big, but it's exciting. And we want all of you to be here with us on this journey. And I think many of you have already joined our Facebook group or follow us on Instagram. We have our website as well. We look forward to continuing to develop more resources. So that's us. That's what we're doing. And anyone has any questions?
If I may, I want to add some excitement here. Actually, I met with Ben and Ashley online a couple of years ago. But 3 weeks ago, that was the first time I met. I saw the Ashley in LA in gene therapy meeting for the first time, and then we both attend the gene therapy annual meeting. So I'm very, very impressed with the effort. The amazing in such a short period of time, what they have accomplished is amazing. I give my promise to Ben and Ashley. I said, well, is there anything we can do to help you to get this foundation move forward? I think that's I'm training as a physician scientist. I always believe research is the answer, for the future for the children. So I think that's what they do is amazing. I think that we fully support, and then I think that actually asked me to help with this joint effort, the clinical expertise, the group joint effort. So I said, well, we'll do it. So that's amazing. Yeah, it's amazing what they do. Thank you, Ashley and Ben. Yeah.
And thank you again, like everyone said, without Dr. Wong and the DDC, there would be no CSA. Without, the CSA and bringing together all these families, because I know that when all of you met, you started the foundation because you never even met another family with Cohen syndrome. And like, look what you've done now. I mean, the way that I met Courtney and Robin to start these efforts are from the parent group that you guys started. So again, we're just so excited about the progress and how our community as a whole can keep, advancing everything.
And I think one of the things too, sorry, it's Ben, you can't see me, but
here,
no,
sit over.
but just, I think Dr. Wong, I mean, right now, the current state of the research is there aren't, relative to other rare diseases, we are a pretty small group. I think that there's estimates that there are a lot more children and adults that are affected with Cohen that have not been diagnosed. And so it's a much bigger group than we realize. But that being said, we only have access to the folks that we know of. And because of the size of our group, that is, makes it harder sometimes to generate scientific interest in the research. We're very fortunate to have started to forge a lot of partnerships throughout industry, throughout academia. But we have here Dr. Wong sitting in front of us, who's bringing researchers to the group with established interest in this disease. And there can absolutely never be enough of that. And I just want to thank Dr. Wong, and I look forward to an enduring partnership and hopefully a lot of funding opportunities so that we can support the just crucial work that he and his scientists are engaged in, because his commitment obviously to Cohen transcends just a casual interest in science. It's his lifeblood. It's what he's dedicated so much of his career to. And I think it's just so important that we acknowledge that and also continue to support him as we move forward in this journey.
Oh.
Thank you for the kind words. Thank you.
Oh, do you want to answer that question?
So a question about my background. So I am an internist. I'm also the chief medical officer at all of UCLA Medical Center. I have done some basic science lab work in a lab back in 2008 with Dr. Benjamin Bodavita, mostly in immunology. Researching is not my forte. I've also published some clinical research as well. But certainly, you know, when you, I have an MBA, I do a lot of management stuff, and we promote a ton of research throughout our hospital. And I'm associate dean at UCLA.
Oh, and if they missed the intro, you're Liam's dad.
And I'm Liam's dad. So I am very familiar with research endeavors. I support a lot of research. We get funding for a lot of research. I myself, I would not characterize as a researcher. And a lot of what I do is try to assess people's capabilities and competencies and try to help and support them as you move forward in terms of funding opportunities, and really establishing infrastructure to put a great research program together. So that's really my background. And again, we're just so fortunate to have someone like Dr. Wong here, who has so much expertise and who knows so much already about Cohen and has so much clinical knowledge of the syndrome and also the basic science. And again, I think with the resources we have, we can go far, but we also need to really build new bridges as well. We need a whole community of researchers around the world who are engaged and interested in this work. 1, 2, or 3 is not going to cut it. We need, it takes a village. Sorry, I'm going on a little bit, but I'll just say we also have interacted with several founders of rare diseases who have actually have therapies currently in clinical trials. One of them is Friedreich's ataxia,
Rett syndrome,
Rett syndrome,
Angelman syndrome.
Angelman, you know, literally a host of some of the most advanced rare disease research. We've talked to the founders of the organization that have actually implemented successful plans. This is a significant undertaking and it requires a tremendous amount of work. We're just so blessed again to have what we currently have, but a lot of what we need to do is really community building, infrastructure building, engaging scientists where they are, emailing them sometimes cold and setting up meetings, and we've started to do that. But again, we just are so excited about this and really look forward to building bridges with you all, because however big my circle is, however big Ashley's circle is, however big Dr. Wong's circle is, or Lisa's or Beth's or Diane's, you know, each of you have your own circle of people, and you never know who is connected to who and where we will find the next person who's interested in Cohen's research. So again, it takes a village, and we really need to build this research community from the ground up, and it starts here today.
Well, we are super excited for what you and Ashley are doing. We didn't know when we started all those years ago, going to see Dr. Wong and, and up there in Ohio, what we were going to do was literally, and it's funny because Dr. Wong said it was like 5 families went to Lancaster. Well, there were 5 of us that started in Ohio. When you said at the end of your presentation, you said we need families to pull together. And so it is kind of funny that it's 5 and 5. So we're super excited because it's with doing that, and even like we didn't know what our path was going to be. We just knew we were going to make a difference. That was our goal, and we've learned to have to adjust, through the ebb and flow over the years to figure out what happens, because everything changed, technology changed. We used to think we needed celebrities to get the word out. What we needed is scientists. We needed parents that were scientists, parents that were physicians, because we really didn't know what we were going to need. So it's really very exciting. So very thankful for you guys. I think you're mute.
Anyway.
Oh, there you go.
Yeah, no, and thank you again, everyone on this, call, the panelists that are here, the CSA board, for all your support. I mean, we're really lucky too. I mean, we just all have the sweetest children, and at the end of the day, we all want to do everything we can to help them live their fullest lives.
Absolutely. Now, are there families that have questions, especially, Ashley and Ben, just about their new research foundation, or Dr. Wong, or the CSA? Like, let's open it up. Like, does anyone have questions that haven't been answered?
I guess my question is Alan's age. Now he's 37. Do you think the impact that is being created now for the young children will also be created for him maybe in 5 years?
Yeah, I think that's such a great question. And I think some of it is to be determined, and I'm curious to hear Dr. Wong's thoughts, because he obviously has expertise in this area. from my experience, if the cells are living, right? So, cells can be damaged, but they can be living. And if the cells are living and you provide the right gene to the right cell, potentially there could be therapeutic options for our children. Of course, as children age and they grow into adults, the damage becomes so significant that the cells often apoptose, which means they die. There's other things that happen, and sometimes the situation is such that they are not recoverable. And so in order to fix, to not fix, because these children don't need fixing, they're just so precious and wonderful. I want to be very clear, we are not trying to fix anything. We're just trying to enhance. We wouldn't trade our Liam for the world, but in order to treat, you need to have substrate. You need to have cells that are still functional, that can receive the genetic material or the drug or whatever it is. And so if for example, the retina is totally denuded of functional cells, it would be very hard to restore any vision, as an example. However, yeah, so when we see the Luxturna story that we were going to actually show, it's a little bit long, it's 6-7 minutes, but I would really encourage you to see it. The one we chose was an individual in his 30s. And so there is definitely opportunities.
Who had been legally blind since he was 7 and now had restored vision and was teaching football practice in the evenings. So
again, I think it really varies. I don't think there's a one size fits all. It probably depends on the organ that you're dealing with. It probably depends on the individual in terms of whether they're a good candidate. There's a lot of testing that goes before they inject Luxturna to really see if it is likely to work and assess the candidacy. But I don't think it's beyond the realm of possibility, certainly, that we could develop treatments in the next few years that would affect both adults and children. Dr. Wong, I'm curious to hear your thoughts as well.
No, you made a great point. I think that a couple of things, I want to, keep it in mind myself is, this Cohen syndrome, this gene is huge. Just like Ben pointed out, it's, a few times more than the normal AAV gene can deliver to body system, and then which is make our work much harder. But other thing I think is also keep in mind is the gene, the protein is a cellular membrane, cross-membrane protein. So which is also make the gene therapy is more challenge. But then again, I think the research is always the answer for me. Gene therapy is only part of the research. We need to keep in mind. And then there is other, as Ben said, was a repurpose the medication and then editing, DNA editing, other potential treatment options. And then even certain medication is more targeting to this particular disease. If we can identify this medication to use that medication, that's also big breakthrough for us. So I think that for the gene therapy, for the patients who are older, may not benefit directly, but there are many other potential benefits we could come out from the research.
Yeah, one of the things too that I don't know that was mentioned, it's not just the basic science research, which obviously is important. And Dr. Wong mentioned something very important, which is CRISPR, gene editing as well. That the technology to actually go in. Right now, we're delivering genes to cells, but there is technology that's available that will edit the genes themselves within the nucleus of the cell. And obviously, that is
to change it.
Yeah, it changes it. It's still in the pipeline, I would say. It's still early, and billion-dollar questions require billion-dollar solutions. And so when we think about something like CRISPR, I don't think we're going to develop the first necessarily CRISPR application, but I think as it becomes more common, certainly we can be early to adopt and apply those lessons to Cohen, which may be one of the more promising treatment possibilities because it is such a large gene. I think the other thing, though, that's really important is that there are ways to improve our children's lives and our adult lives well before we even develop treatment. So how many of you, I could just ask by a show of hands, I don't know if you can respond, but have had problems getting a treatment covered, like Neupogen or like growth hormone?
Or even the durable medical equipment that I had to appeal Anthem 5 times to get his Ripton activity
Yeah,
care.
we couldn't get, literally, we had to appeal to an authority that oversees our insurance company to actually get a lot of the durable medical equipment that Liam needs every day. We can only imagine. I'm a physician. Ashley has a master's in health education. what about, parents who are, don't English isn't their first language and they don't necessarily have the same health literacy? How do they access these treatments? And so, and supports. And so part of the goal of the clinical research side as well, which I think will benefit everybody, no matter how young or old, is to establish best practices and establish data that actually demonstrates with scientific precision that interventions help. Neupogen may reduce infections, or growth hormone may improve hypotonia, or the Rift and Chair reduces the risk of safety events, or they need general anesthesia for a dental procedure instead of local anesthesia within a dental office, because we know that children that have local anesthetic without the supervision of like a hospital system are at risk of death, which we know our group suffered from and is an absolutely horrific outcome. In order to demonstrate that to insurance companies, one of the first things, and unfortunately I have to deal with this all the time, they ask is, well, show me the literature. Show me the data in the scientific literature that supports what you want. Again, right now, we have very little of that. And this is, again, where Dr. Wong's partnership is just so crucial. How do we demonstrate to all of these different insurance companies with scientific data that these things matter for our kids and our adult children? And I think that, again, we want to look at the moonshot. We want to look at, how we do gene therapy and CRISPR and all these other things. But there are a lot of things we can do tangibly on a day-to-day basis to improve our children's lives that are absolutely not dependent on, again, these monumental advances in the world of gene therapy and CRISPR technology and such. So I just want to emphasize, it's not an all or nothing. It's not like we develop a Luxturna analog or we don't. There's so much we can do in between where we are today and developing those treatments. And again, we just need your support for it.
Exactly. And like, just to give a practical application of the paper that we're working on with the UCLA working group, there is a section on anesthesia. And one of the Cohen syndrome parents reached out to me and said, hey, they're denying my child to get anesthesia in a medical setting. And I reached out to the anesthesiologist who wrote it. And even though it was still a draft, he said, sure, share it. And I think it was able to help her reach that goal. So I think it was really wonderful too. I've been so humbled and amazed that, the medical community, Dr. Wong, the doctors we talked to, they want to help us.
So a couple of things from the chat that I just want to address. One question was about kyphosis. Obviously, kyphosis is really important. It has to do with the curvature of the spine, for those that haven't, witnessed that. And so if our children are hunched over, it has all kinds of orthopedic implications. It has, it's really important. That's one of the reasons why we want to send. I am not aware of any research that's being done into kyphosis, but obviously low muscle tone will, if the body doesn't have the strength to support the spine and all of the upper extremities, you'll see more hunching. And so I think that's why we really need to solicit feedback from everyone on this group to say, what are your priorities? What are the things that are really affecting your children's lives and your loved ones' lives that we need to be looking at? Because we know what our experience is, but our experience is not universal. We need to understand what all of your experience is. And so we look forward to getting your feedback. And I hope that you'll respond to the survey and let us know, is there a significant desire for kyphosis research? Another question about Illinois, I'd love to talk offline. There's absolutely going to be great resources in Illinois. I mean, Chicago is in Illinois. There's a number of great institutions there. Again, I can't imagine there aren't people who are expert geneticists and clinicians within the Illinois region that could provide that information. I also know of a number of people in Michigan, for example, Dr. Walkovich's group, who I think was represented today on our call, is not too far in Michigan. So absolutely, we can talk potentially offline. Please reach out to Ashley or myself so that we can hopefully connect you with resources. We've actually been doing that a lot. So people have been reaching out to us from all over the world. We had someone in Abu Dhabi, someone in Lebanon, places we never even knew about, people coming out of the woodwork. And we've actually connected them with, for example, the Mayo Clinic in the Gulf. And they've been getting unbelievable treatment and therapy. United Arab Emirates as well. And so there is a community of people again, and if we put our minds together, we can start to map out all of those resources across the world for our families of those that have Cohen syndrome. Another person remarked, Lisa, I saw, that was denied Neupogen. Again, if we had better data, and I know Dr. Wong could help us with this, if we had better data, we could for sure, present that to insurance companies to make sure that was never denied again. And Ashley will put her contact information in, but so much of this really comes down to community building, sharing information, taking best practices, and then studying it. You know, we got to study it systematically so that we can respond to the insurance agent who says that this won't make a difference in your child's lives. We saw that very early on with Liam. They wouldn't even do genetic testing on him. They said, with the response that we got after 4 appeals was, it won't change his outcome.
His
So
management, which is crazy because he was sick all the time and we still never understood that it was neutropenia.
So again,
Yeah, we're all on this together and thank you again, everyone.